machine translation. So in-domain data scarcity is very common in translation settings. You might be familiar to this situation when that inspired our paper. You might get a big translation project or a big client, but you have a very tiny in-domain translation memory, or you don't have a translation memory at all. Recently, there has been a huge advancement in the area of large language models. Here there are only just a few examples of autoregressive language models that can predict next word in a sequence. More specifically, for our paper, we used GPTJ and MGPT. And the idea basically was, if you give this large language model a translation like the target side or a sentence, the thing is it continues similar sentences that simulates the domain and the linguistic characteristics also of the sentence that you just gave. Inspired by this simple idea, we investigated two setups. So the first setup is when you have a small in-domain translation memory, very tiny translation memory that might not be enough to fine-tune your baseline machine translation system. And the second step is when there is no in-domain translation memory at all. So in the first step, we have 3 steps. The first step is that we use each target sentence in your tiny translation memory to generate text using a large language model in the same target language. The second step is to generate the source using back translation in the other direction. And this back translation, of course, also machine translation in the other language direction. The last step is to apply mixed fine-tuning using the in-domain synthetic data you have just generated from the 2 previous steps and a portion of the generic data used for training the original generic model. In setup 2, you don't have target sentences, but you have the source text that you wanted to translate. So you can use an initial step of forward translation with the baseline model, the baseline machine translation model, to generate the target. The target wouldn't be perfect as human translation, but it will have some domain characteristics so that you can apply this, the 3 steps from setup 1. This is a quick overview. I'll try to give more details in the next slides. So basically, this is how maybe you can load a model like GPTJ, and you might need to apply some tricks like float 16 or other options from Hugging Face to make sure that it fits into your machine. And currently, they have also new models using 8-bit, which is more efficient. We didn't use the 8-bit, but this is also will make loading models more efficient and possible. This is the most important step here, which is generation. As you can see, you take each translation memory segment and more specifically, the target segment. The segment in target language, each sentence, and use it to generate multiple sequences. Here, for example, we generated 5 sequences. Each sequence might include multiple sentences. So after this, you will use a sentence splitter to extract, to generate, to have sentences. And obviously, you'll apply filtering like language model, language detection, removing a very short, too short sentences, removing too long sentences, etc. So basically, each target sentence from the translation memory will generate several sentences that hopefully simulate the domain characteristics and the linguistic characteristics of the authentic the authentic target segment. Here are some good examples that are generated by the language model. As you can see in these examples, these are both semantically correct, linguistically correct, and they are possibly a fact. When we say in March 2020, India ordered a countrywide shutdown, this seems true, and it's linguistically correct as well. The second sentence as well is linguistically correct and possibly a fact. Here is another set of examples that seems like semantically correct, but maybe it has or they have some tiny mistakes, like the number of years might not be inaccurate. Maybe some names of animals, people, etc. So both quality are okay, but obviously, if the quality of the generated sentences by the language model isn't good enough, isn't good at all, this will affect the quality of the machine translation model. So basically, the better the text is generated by the language model, the better the quality that you can get when you later fine-tune your machine translation system on this synthetic data. So basically, after this step of text generation with a large language model, you have the target side. And you don't have the source side yet. To generate the source side, you use back translation in the other direction of another machine translation model in the other language direction. So now you have the target and the source, and both the target and the source consist of synthetic data. The target is generated by a language model, and the source is generated by back translation with machine translation. The final step is applying mixed fine-tuning of the baseline machine translation model on this bilingual synthetic in-domain data set. And mixed fine-tuning means that you will have your synthetic in-domain data set and a randomly sample of your generic data, a randomly sampled portion of your generic data set originally used for translating the baseline machine translation model. And here oversampling is an important step. It basically means if the size, assuming the size of your in-domain synthetic data set is 1x, the generic data set will be, for example, 9x, and then you will apply weights, like reverse weights. So the generic data set will have only 0.1 weight, while the in-domain data set will have, for example, 0.9 weight. And the reason of this is to make them look like they are equal, virtually equal. So after you fine-tune your original machine translation baseline on this synthetic data set, and of course a portion of your generic data set. As you can see here, we applied this for Arabic English and English Arabic. And step one, as we mentioned, is when you have a tiny translation memory, while step two is when you don't have translation memory at all. As you can see here, results are good, and here blue score is better, like 5 blue score better, and other automatic metrics as well. And also human evaluation correlates with other automatic metrics. And this is for both Arabic English and English Arabic. And there is an important point here. You will notice that setup 1 in both languages is better than setup 2, which is expected. Still, setup 2 is better than the baseline machine translation model. If you'd like, you can download our configuration scripts and configuration and the scripts, and also you can see detailed human evaluation. You can scan this code and you will be able to get the link to our GitHub repository. Thank you very much for watching, and I will be happy to answer any questions. I can't hear the host, but I can answer questions from.
Okay.
Okay, I'll answer the question I can see in the chat. So from Michelle, if I understand correctly, you use text generation feature of GPT to build an in-domain corpus using back translation. What I am not understand is how you see this text generation. Okay, in models like GPT, you basically fed the model with a prompt, and this prompt will, the model will generate more text based on this prompt. So in our case, the setup, the first setup, we have a tiny translation memory. So we use each target sentence in the translation memory, or we can call it a bilingual data set, but it's a small in-domain bilingual data set. We use the target side of this translation memory or data set. Each sentence, we use it as a prompt in the language model, and the language model will start generating more text based on this target sentence. And interestingly, it will simulate the characteristics of the authentic sentence. Could you have used a term extraction as a prompt, or does it have to be full sentence? Okay, term extraction we didn't investigate in this paper. We intended to postpone it for future work, but I'd like to mention one important note about term extraction as a prompt. If you just use a term, this might not give a good sentence. The best thing is to do is to have sentences that include this term and use these sentences as a prompt. But still, we didn't investigate it in detail. But if these are two cases, if you use that term and it didn't give you good result, try to rather use sentences that include these terms. Thanks, Michelle. I'll move to the next question. How different is mixed fine-tuning from downsampling and upsampling? The weights basically seem to be the temperature of sampling, or is there something more to it? Okay, oversampling, here weights simulate oversampling. So I think you get it right that yes, this is oversampling, and or sometimes it's called upsampling, and basically in some let's say in some machine translation systems, like in some machine translation systems like and some machine translation systems like OpenNMT, they use weights to replicate or to apply oversampling or upsampling. Yeah.
Thank you. I think we should move on to the next paper. Yeah. Thank you, Yasmin.
Thank you very much. Thank you. Goodbye.
Okay. The last paper is. Thank you. The last paper is Strategies for Adapting Multilingual Pre-training for Domain-Specific Machine Translation.